The arrow of time is a concept in physics that describes the one-way direction or flow of time, where time seemingly moves forward and not backward. It is a concept deeply embedded in our everyday experience. For instance, we remember the past but not the future, and physical processes, like a cup shattering or an ice cube melting, seem to occur in only one direction. This forward progression of time is an area of active inquiry in physics, and several theories attempt to explain why time flows in this specific direction. The primary explanations for the arrow of time stem from different aspects of physics. ###1 Thermodynamic arrow of time. The most widely accepted explanation for the forward flow of time is rooted in the second law of thermodynamics which states that in an isolated system, entropy, a measure of disorder, tends to increase over time. Entropy can only stay constant or increase, never decrease spontaneously in a closed system, and this continual increase in disorder leads to an irreversible flow from lower to higher entropy states. For example, once a cup shatters, it cannot spontaneously reassemble. Similarly, heat flows from hot to cold rather than the reverse, establishing a directionality that aligns with our perception of time's progression. ###2 Cosmological arrow of time. The cosmological arrow of time is associated with the expansion of the universe. Observations indicate that our universe has been expanding since the Big Bang, which contributes to the forward flow of time. In theory, if the universe were to stop expanding and start contracting, the direction of the cosmological arrow of time could reverse, possibly impacting our experience of time. However, this is speculative, as there is currently no evidence to suggest that such a reversal would cause people to experience time backward. ###3 Psychological arrow of time. The psychological arrow of time refers to our perception of time as moving from past to future. Humans remember the past but not the future, which reinforces our subjective sense of time moving forward. This perception may be tied to the way our brains process information and form memories. As we experience events in a sequence and retain memories only of past events, it constructs a sense of time that flows in one direction. ###4 Quantum arrow of time. Quantum mechanics introduces complexity to the understanding of time, particularly with wave function collapse in quantum systems, where a quantum state becomes a specific outcome when measured. Some interpretations suggest this collapse introduces a directionality in time, as observing a quantum system seems to create an irreversible state. ###5 Gravitational arrow of time. The gravitational arrow of time may also play a role, particularly in how gravity contributes to the structure of time's progression. As structures in the universe form under gravitational forces, like stars and galaxies, these formations mark a forward-moving process from simplicity, a diffuse cloud of gas, to complexity, stellar formations. This is linked to entropy, as gravity contributes to increasing the universe's complexity over time, establishing a directional progression. ### Is time truly moving forward? Physicists debate whether time truly flows forward or if this flow is an emergent property of other processes, such as entropy. Time reversal symmetry * in some fundamental physics equations suggests that at the microscopic level, time could, in theory, move backward as easily as forward. However, on macroscopic scales and in practical terms, time appears to advance, and this may be more a result of initial conditions, like the low entropy state of the universe at the Big Bang, than an inherent quality of time itself. ### Conclusion. The concept of the arrow of time aligns with several physical laws, particularly the second law of thermodynamics, the expansion of the universe, and our psychological perception of past and future. The combined effects of these factors create a coherent understanding of why time appears to move forward. While some laws of physics allow for time symmetry, the entropic increase in an isolated system and the ongoing expansion of the universe provide a compelling basis for why, practically speaking, time progresses in a single direction.